Hello class 6. We are discussing, if you remember, applications of rectilinear propagation of light. Now what is rectilinear propagation of light? Rectilinear propagation of light simply means light traveling or moving in a straight line, remember. So the word rectilinear means straight line. So the first application of rectilinear propagation of light is in a pinhole camera. We've actually already discussed this, so very briefly let me give you a recap. So it is simply a box. You can make a pinhole camera out of a cardboard box, which of course, since it's a box, it's closed from all sides. Now what you do is you simply make a very small hole, such that when you place an object, could be a burning candle, in front of the pinhole, then on the opposite side, the side which is opposite to the side containing pinhole, so I'm talking about this side, so this side will be your screen. What you can do is, instead of a cardboard itself, you can replace the cardboard by a tracing paper. So the tracing paper on this side of the box will act as the screen, and what is seen is, you will see an inverted image of the object. Like I've told you, you might not actually see this wax part of the candle. Okay, you might only see in the image you might only see the inverted flame burning. Alright. Okay, so then after we discussed two important things regarding a pinhole camera, that is, the first thing is the factors affecting the size of the image. How can we increase or decrease the size of the image? So there are basically two factors. First is the distance of the screen from the pinhole, that is the distance of the screen from the pinhole. It is seen that more is the distance between the pinhole and the screen, then what happens is the bigger will be your image. Furthermore, the size of the image is also dependent on the distance between the object and the pinhole. More is the distance between the object and the pinhole, bigger will be the size of your image. So remember, these are the two factors on which the size of image formed in a pinhole camera is dependent. But get one thing very clearly: bigger the size of the image, fainter the image will be, remember that. So if you want to get a very distinct, clear image, okay, the distance between the object and the pinhole should be small. Likewise, the distance between the screen and the object should also be small. So if we decrease the distance between the screen and the pinhole, or we decrease the distance between the object and the pinhole, you will get a brighter, sharper image, but it will be a smaller one. Then the other thing that we studied about is the characteristics of the image formed by a pinhole camera, of course. So what is the behavior of the image like? That is what is called the characteristics. What is the character of the image like? Okay. So the first thing you see is, in the picture itself, you can see that the image is inverted. This is an erect object, upright, whereas the image is inverted, upside down. So the first character of the image is inverted. Now I have told you, remember, whenever you see an inverted or upside down image, that kind of an image is called a real image, remember. So the very next thing you write is the image is real. You see the image is inverted, so you write image is inverted. Now the moment you see an inverted image, you have to understand it is a real image. So you write the image is real, that is the second characteristics. And the third is, usually the image is smaller in size compared to the object. Okay, so these are the three characteristics of the image formed by the pinhole camera, remember. Let us now, class 6, talk about another application of rectilinear propagation of light, which is the formation of shadow. Now, you must have observed that when we stand in broad daylight, say for example the sun is shining very bright and we are standing, then what happens is, we will see, if light is coming from this side, from my left side, say for example, we will see our shadow formed on the ground, on the floor, or could be on the wall. Okay, we will see a dark patch, a dark portion that is formed. So that dark patch which is formed on the screen. The wall is acting like a screen then, or the ground is acting like the screen when we are standing in broad daylight on a very sunny day. So the dark patch that is formed on a screen when an opaque body is placed between the screen and the source of light is what is called a shadow. So the source of light in our case, therefore, in our example, is the sun, and the wall or the ground is your screen. Okay, so that dark patch which is formed when an opaque body, we are the opaque body, remember, and do not forget, an opaque body does not allow light to pass through it. Okay, so this happens, a shadow is formed in case of an opaque body, remember. So when an opaque body is placed in between the source of light and the screen, then a dark patch is formed on the screen which is called the shadow. Now, a shadow can be divided into two parts, or rather we can say a shadow is divided into two portions. One is called the umbra region of the shadow, and the other is called the penumbra, P-E-N-U-M-B-R-A. Now what is the umbra region? Whenever shadow is formed, what happens is we basically see a very dark patch of the shadow, the darkest region of the shadow, where of course no light reaches from the source of light, is what is called the umbra. And the penumbra is a portion or region of the shadow which is not completely dark, which is very faintly dark, so to say, which is dim, so to say, or less bright. So that region of the shadow is what is called the penumbra. Okay, now let us take this example. So we consider the candle to be a point source of light, and we have an object, a basketball, say for example, at some distance from the candle, and we have the screen behind the opaque body. A basketball is the opaque body. So what happens is, since light travels in a rectilinear path or a straight line path, so light starting from the candle, light is traveling in this direction. We see a dark patch formed on the screen, the dark patch of the opaque body. This dark patch is what is called the shadow. In between these two lines, there are other rays of light starting from the candle, of course. But these rays of light are completely blocked by our opaque body. No light, rather, in between these two rays of light are going to reach the screen. So therefore, this portion of the screen will be completely dark. And to be more precise, and that of course is what is called the shadow, remember. To be more precise, this region of the shadow is called the umbra region. This darkest part is what is called the umbra region of the shadow. Because in this part there is no light from the source of light reaching. So this is what is called the umbra region. Let us now discuss about the formation of umbra, or could be umbra and penumbra together. Alright, so these are all shadows, remember. Okay, different regions of the shadow is what is called umbra and penumbra. Okay, now when is a shadow formed? Whenever an opaque body is placed in between the screen and the source of light, a shadow is formed, remember. Alright, so let us talk about formation of umbra alone. If you have an opaque body placed, of course, between the screen and the source of light, but your source of light is a point source of light. Like for example, we have a candle and we place a cardboard, say for example, in between the opaque body and the candle, and we make a small hole on the cardboard. So this is a cardboard here, okay, which is blocking the candle or the ray of light, and you make a small hole such that the rays of light are passing through the small hole that you've made now. Okay, so the small hole is acting like your point source of light in this case. Now whenever we have a point source of light, since rays of light, they travel in a straight line, So we have rays of light moving in this direction and in this direction from the source of light. Of course, do not forget there are other rays of light also in between these two rays of light. There are other rays of light also starting from the point source of light. But all of these rays of light are blocked by our opaque body, because opaque body does not allow light to pass through it. All rays of light in between these two extreme rays of light, they are all blocked by the opaque body, such that what happens is on the screen you get a dark patch which is of this size. So therefore what we have is we have a very dark shadow formed, which is your umbra alone. There is no question whatsoever of a penumbra forming in this case when the source of light is a point source of light. So do remember, whenever we have a point source of light, then only umbra is formed. We only see umbra, no penumbra whatsoever. The next formation of shadow is where we see both umbra and penumbra. Now we get to see umbra and penumbra both when we have an extended source of light, a big source of light, so to say. Like for example, a candle, and we have an opaque ball, a tennis ball, say for example, in front of the candle, and we have a screen placed. So you can see these two white extreme rays of light starting from the two ends of the flame. So you have these two rays of light, they pass through the two extremes of the ball, and here is where the darkest part of the shadow is formed. This is called the penumbra. Now in between these two white rays of light, there are other rays of light also. Now these rays of light are completely blocked by our tennis ball, our opaque body, such that in between these two rays of light, no rays of light are reaching the screen. So no rays of light in between these two extremes are reaching the screen. But a ray of light from here is also traveling in a straight line, and it passes through the upper part of the ball, and starting from the upper part of the flame, it passes through the lower part of the ball. It just touches the lower part of the ball and reaches over here. Okay, now what happens is the rays of light starting in this direction. So these rays of light, what happens is partially in this region, inside this circle, what happens is rays of light partially reaches the screen. Okay, we have a ray of light starting here. So this ray of light will be starting from this part. Another ray of light will be starting from this part. So here also a ray of light here will be starting from this end of the flame. Another ray of light will be starting from this end of the flame. So what is happening is, in between these two extreme rays here, depicted by orange rays of light, there are some rays of light reaching this part of the shadow. So this part of the shadow therefore is not completely dark. It is dim, it is less bright, but not completely dark, remember. So we have the central portion here. This central portion is very dark and it is called the umbra. Now surrounding the umbra, the penumbra will always be surrounding the umbra, remember. So surrounding the umbra, we have another less dark, or rather dim patch. Okay, so that is this region, so to say, is what is called the penumbra, remember. These pictures are there in the book also. If you learn how to draw these pictures, it will be good for you. Alright, class 6. So this is how both the umbra and penumbra region of the shadow is formed. Now, this third case, actually it's not there in the syllabus, but still let us discuss this. This is the formation of penumbra only. Okay, so we have, if this is the case when we have a very big source of light compared to our opaque body. So here is our opaque body, a small opaque body compared to our source of light. So what happens is, This white rays, they start. Alright, so it is these two rays of light which contributes to the formation of umbra, and these two orange rays of light, they contribute to the formation of the penumbra. If you have the screen very close to the object, then what happens is, or if very close to the opaque body, then a small umbra region is formed here, small umbra region, and surrounding the umbra region you have the penumbra. But if we take the screen farther away from the object, which is depicted by this picture, then you can see a very point-sized umbra region is formed, whereas the penumbra is a bigger portion, bigger region of the shadow surrounding it. Okay, whereas you only have a point source, or point umbra region. You farther away take the screen farther away. What happens is your umbra completely disappears. You only have a bigger penumbra region, bigger than this. Okay. Now, therefore, for penumbra only to be formed, so this is the case where only you get to see a penumbra, no umbra. So this is the case which is true when the source of light is much bigger compared to our opaque body, and the distance between the screen and the opaque body should also be large, because when the opaque body and the screen they are very close to each other, you get to see a small umbra region. But if farther away, you go on taking the screen farther away from the object, your umbra region completely disappears. This is what happens when a bird or a kite is flying on the sky. It's flying in the sky. So you have a bird flying, you have the sun, but do we see the shadow of the bird on the ground? We obviously do not see. Why? Because the sun is a very big source of light and a bird is a small creature. Small thing flying in the sky. Okay? So small thing flying in the sky. So what happens is the shadow of the bird is not, the ground is acting like the screen in that case. So you do not see the shadow or the umbra region of the bird. Now of course penumbra is formed, but since the distance between the ground and the bird is also large, okay, so the penumbra is very big. Penumbra of the bird, penumbra region of the shadow of the bird is very big. Now, bigger the penumbra region, fainter it becomes. So therefore, since the penumbra region is very big and very faint, therefore we do not see the shadow of the bird cast on the ground. When a bird, we see a bird flying in the sky. Okay, so this is about formation of shadows, formation of umbra and penumbra. Okay, basically.